All right, let's talk about something you've probably seen 1,000 times but never really thought about. Yeah, I'm talking about that little red box on the wall. It's one of those things that's just there, but it's also a silent guardian, a first responder, and honestly, a brilliant piece of design hiding in plain sight.
No, I mean, seriously, think about it for a second. In schools, offices, shopping malls, you've walked past hundreds, maybe thousands of them. And that simple little box, it tells this fascinating story about human behavior, emergency response, and this constant tricky balancing act between speed and safety.
So at its most basic level, the problem is super simple, right? You see a fire and you need to warn everybody, fast. So what's the most direct solution? Well, it's a simple box that does just one thing.
So let's get the definition out of the way. A pull station is really just a manual switch. That's it. You activate it and boom, it triggers the whole building's fire alarm system. We're talking the sirens, the flashing lights, the whole shebang. It's basically your voice when you need to shout fire to an entire building at once.
Okay, so the very first, most basic design is what's called a single action station. And its genius is just how simple it is. There are no tricks, no puzzles, no messing around. You see the handle, you pull the handle. That's it, the alarm goes off. In a moment of pure panic, you don't have to think, you just act.
And this is where we get to the core trade-off. The good part? It's incredibly fast and intuitive. Anyone, and I mean anyone, can use it in a split second. That saves lives. But the bad part? Well, it's too easy. An accidental bump from a backpack, a curious kid, a prankster, all of those can lead to false alarms. And false alarms are a huge, huge problem.
In fact, that problem of false alarms got so bad that it forced a total rethink of the design. Because here's the thing, when an alarm goes off for no reason over and over again, what happens? People stop trusting it. They start ignoring it. And a safety system that nobody trusts is a system that's completely broken.
This quote really nails it. The biggest weakness of a simple solution is a simple mistake. Think about that. When your entire system can be activated by one simple action, it means one simple mistake or one stupid prank can trigger this massive, disruptive, and super expensive emergency response. The solution couldn't just be simple anymore. It had to be smarter.
So what was the big idea? What was the fix? Well, it was actually pretty simple. They introduced a second step. Just a small, simple barrier that forces you to make a conscious, deliberate choice before you can sound that alarm. And that brings us to the dual action station. Instead of just yanking a handle, now you have to do something else first. Maybe you have to lift a clear plastic cover or push in a little plate. It's not hard, it's not complicated, but it's just enough to make your brain pause for a split second and go, wait, am I sure about this? And that one little pause filters out almost all of those accidental alarms.
And then, of course, you've got the most extreme version of this, the break glass station. Now, this is the ultimate dual action device, right? Because you can't accidentally break glass. It takes real force, real intent. That's why you see these in places where preventing a false alarm is the absolute #1 priority.
So here's a quick side-by-side of the two philosophies. The single action, one move. Its main goal is pure speed. You'll find it in pretty general locations. Then you've got the dual action. Two moves. Its main goal is preventing those false alarms. And you'll see this all over high-traffic public places. Think schools, malls, college dorms. Anywhere the risk of an accident or a prank is just a little bit higher.
But sometimes, even a dual-action design isn't quite enough. You've probably seen these, right? These big, clear plastic covers, they're often called stoppers, that go over the whole pull station. They do a couple things. Yeah, they protect it from dust and stuff, but more importantly, they're another psychological barrier. It just makes it a little bit harder for someone to casually mess with it.
And then for the maximum level of protection, you've got these wire guards. Just picture a school gym. A basketball goes flying, hits the wall. An exposed pull station could easily get damaged or even set off. This metal cage completely prevents that kind of physical damage, while still letting someone reach their hand in to activate it during a real emergency.
Okay, so we've spent all this time talking about the design of the box itself. But here's the thing. A perfectly designed device in the wrong spot is totally useless. Where you put these things is just as important as how they're built. And believe me, it is not left to chance.
In the US, there's actually a super detailed rule book for this, called NFPA 72. It's the National Fire Alarm and Signaling Code. This is the playbook that architects and builders have to follow to make sure that, in an emergency, you can always find a pull station right when you need one. Let's look at the 3 biggest rules.
First up is height.
The center of the pull station can't be more than 1.22 meters, or about 48 inches, off the floor. Now that's not some random number. It's all about accessibility, making sure someone in a wheelchair can reach and operate it just as easily as someone who's standing.
Okay, second rule, it has to be within 1.5 meters, that's about 5 feet of an exit doorway. And the logic here is just brilliant. Think about it. In a fire, where's everyone running? To the exits. So you put the alarm right there so someone on their way out can pull it and warn everyone else.
And rule number 3, you should never have to travel more than 61 meters, or 200 feet, to get to a pull station. This rule is a guarantee. It means that no matter where you are in a building, help is never too far away. If a building is huge, the code just says, nope, you need to add more stations.
So when you put those three numbers together, 1.22, 1.5, and 61 meters, you see they're not random at all. They work together as a system designed to make sure these devices are always visible, always accessible to everyone, and always located right where you'd instinctively look if you were trying to escape.
And really, everything we've talked about, the single action versus the dual action, the plastic covers, those specific placement rules, it all boils down to one single fundamental challenge in safety design.
And that is the eternal question. Do you design for speed, or do you design for safety from mistakes? The single action design says speed is everything. We need a rapid response, even if it means some false alarms. The dual action design says, hold on, let's prioritize accuracy. Let's add a tiny delay to make sure the alarm is real. And here's the key. Neither one is wrong. They're just different answers to the same complex question, and the right answer depends entirely on the environment.
So the next time you walk past that little red box on the wall, hopefully you'll see it a little differently. Not just as a fire alarm, but as a really clever solution to a life or death design problem. Which leaves me with one last question for you to think about. Where else in your everyday life do you see this hidden battle going on? This trade-off between making something fast and making it safe?